So from now, I will hand over to Hubert. So
Thank you
have
very
fun.
much. Have fun. Yeah, I hope everybody is prepared for a little bit of tech stuff because this is going to be technical. But yeah, thank you for inviting me here. Thank you for giving me the opportunity to, for the first time in 18 months, to actually see live people again instead of being stuck at home. So I hope, I'm guessing that's true for more people here in the room. Definitely is for me. So yeah, thank you very much. Yeah, Hubert Heijkers. I've been with Applix now for 16.5 years. So working on the engine effectively for that period as well. I'm based in the Netherlands, that's why it's so relatively easy for me to be here. And today I want to give you a little preview about what we've been working on. Actually been working on for quite a while, but it's starting to come together, right? TM1. Version 12, as some people have heard of, Exciter, there have been a bunch of names, but the version number is going to be 12 for the TM1 engine. But as a customer, right, you guys will all be using planning analytics, whatever version that will be, that will contain that server engine. So without further ado, I did this. I hate these slides, but I did include in this because I'm showing stuff that might or might not get there, might change, probably will change to a certain extent. And just to be very clear, that don't make any big plans yet.
I guess we have some problem that it's rubbing somewhere. So just go on.
All right. So I want to do a brief update on TM1 Server, where we stand today, effectively what it has, what we've done recently a little bit, and then immediately dive into future stuff, future-related stuff, as it pertains to TM1 Server, the database engine itself. Not planning any of the clients and stuff like that. I'll leave that to Christian later in the afternoon. I'll be focusing purely on the server engine. And as we're moving towards the cloud and it being a proper service, and since talking about it, it's not that much. I'll try and spend quite a bit of time on demoing it as well as where it stands today, and I'll leave quite a bit of time towards the end as well for questions with regards to TM1 today, TM1 future, whatever you want to ask me with regards to TM1. And as Henry said already, just start firing those questions in the chat as well, so that we can have, we'll try and answer them all towards the end. So quick update. Last year I showed this slide as well, because it's been important that's in a change effectively of what we're trying to do going forward. We're moving towards a new model in how we develop, but before that we did a big push on quality. And the reason I bring it up again is because we're now a year and a half further than when we actually released our latest minor version of TM1, which was TM1 11.8, Planning Analytics 2091, I think it was packaged with. And it was a major shift for us in quality. It was really good. Has been proven to be really good. The number of escalations for the TM1 server have gone down to virtually 0 since that version, which is, not saying we don't ever have a crash anymore, but it's gone down seriously significant. In that version, we called that version the long-term service release. The long-term service release means this is the version you guys are going to use until you're moving to the cloudified version, which we'll talk about in a minute. It's maintained, but we're not doing any major new functionality in this version anymore. But it's not like some people thought that we've dropped it and we're not doing any work on it. I just quickly checked yesterday. It's 762 commits to the source in exactly a year time. So there's quite a bit of maintenance going in, quite a bit of fixing, all kinds of stuff, right, which is still driven by the market and based on cases, and it'll continue. This version is set. The long-term service release to be set to be supported at least till the end of 2024. So there's no rush on moving anywhere else either. So what did we do in 11.8? Things like, monitoring your activity that people typically do with TM1 top log and then have a top running somewhere, and then sometimes people have top running in multiple places, which causes its own set of problems. Now you can have the server run the top log for you, and you don't have to have that separate process anymore. That's since 11.8 already. Asynchronous execution of TIs from within TI. If you haven't heard this yet, instead of like execute process, you can have run process now. But run process is different with execute and run process is that run will actually run it completely asynchronously. So it just fire it off and forget about it effectively, right? But from within the process, so you get a little bit more control there. I think I spoke extensively about Git integration last year because that was the biggest thing, but it is big and it's getting picked up by a lot of people, and if I understand correctly, there will be a demo later on, so don't need to dive too much into that. It's been good for us, and it's actually based on some technology that we actually did develop for the next version of TM1, which we'll touch on a little later as well. Crash dump processing tool. If you haven't heard about that one, and if you ever have a crash of TM1 server, which hopefully if you're on 11.8 you don't have anymore, collect that crash dump, the full crash dump. This utility will actually wipe all the data in your cubes from the dump, because that was typically something customers don't want to give the data to IBM for analysis, right? This utility wipes all the data from the dump, zips everything up that we need for further processing, and then you get a zip, effectively a TGZ file, which you then can provide to support, which is typically just a small fraction of size of the complete dump, which makes analysis of issues a lot easier. Plus, it gives us more insight into the things that are going on, that are typically causing issues with customers. If you are using Git, we did extend a couple of things in 11.3. We added support for HTTP proxies, because typically servers are behind some kind of firewall and they do like servers to directly communicate to the internet, which makes HTTP protocol a little bit hard to consume. So we added support for HTTP proxies, as well as SSH, which is the more typical way to interact if you have your certificates and stuff like that with Git repositories, and TM1 can do that now too. We improved our core. So this is very specific thing. So cross-origin resource sharing, which is something that helps you protect your applications and stuff like that, especially applications running in a browser. And to that extent, we always supported the CORS protocol if the browsers are sending us requests, because otherwise they would refuse to do certain things in interacting with the server. But we always allowed all origins to be, it didn't matter where the request came from. With this improvement, you can whitelist what the origins are. You are allowing scripts to come from typically that are allowed to interact with TM1 server. Ironically, the original thing was the, allow list. Actually, this is wrong, I just noticed. It says HTTP origin whitelist. And since Black Lives Matter, that's not appropriate anymore, so it's allow list. I should have updated the slide accordingly. So it's called allow list. We also added a configuration parameter, which might be interesting in some cases, because we had a client, I won't mention names here, but most people will probably know it. I mean a client application that started to fire enormous amounts of requests in parallel against the TM1 server, and I've seen a case where it was more than 220,000 coming from one client machine. That's effectively a DDoS attack. You're just bringing the server down because you're firing so many requests at it at the same time. So we've added a session max request configuration parameter that you can set through the REST API, obviously, as well, to limit the number of requests that any session can create in parallel against the server. And then there is a couple of new TI functions that we did recently. It's actually not even out, it's 11.8.9, which is out in a couple of weeks. Things like subset alias get, and what was the other one? Or we had a set, but we don't have a get, and you can publish a view, a private view, but you can't publish a private subset, which means if you have a private view that has private subsets, then that wouldn't really help you much, right? So that we're plugging holes effectively in the TI functionality. If there's more missing ones like those, please let us know. They should all be relatively easy to add. So that's what I want to say about an update, right? So keep in mind, 11.8 is here to stay. It's the most stable version of TM1 that we've had for as long as I've been involved with TM1 for sure. And we're maintaining it, and we're trying to improve it wherever we can. It will be, in that long-term service release mode for quite a while, as this will be the last version of TM1 Server as you know it. So switching gears a little bit to, IBM, right? So everybody knows IBM got acquired by Red Hat. Oh, I should say this the other way around. Red Hat got acquired by IBM, right? And since that acquisition and the change in management and the change in strategy, pretty much everything is hybrid cloud and AI. IBM wants to be all in on hybrid cloud and AI. It wants to be the hybrid cloud and AI company, right? That's it. And everything else is secondary to that. So planning analytics, Cognos analytics, and the products we work on, right? At the end of the day, we have to fall in line with the overall corporate strategy and make sure that we play along there as well. And it's all because they feel that customers have to have this clear path to modernize their infrastructure and the environment where they're running their mission-critical applications. So what does that mean for us effectively, right? So while we can talk about a lot of TM1 functionality, right? This means we have to be able to deliver so how we deliver, right? And where we deliver. And effectively, if you follow what IBM's saying, is so everything's going to cloud packs, right? And cloud packs is, if you're running stuff on-prem, you're running on a cloud pack typically, and you'll have your services or your applications available on those cloud packs, or you'll have an equivalent of that in the cloud. At the end of the day, they're kind of the same thing. It's like a mini cloud that you're built yourself on-prem, right? So the cloud pack has everything in it for that, or you're leaving the cloud management and running the whole cloud up to a vendor, right? Obviously, IBM Cloud has those things. So CPDAAS is the abbreviation, I think, Cloud Pak for Data as a Service. But Cloud Pak for Data as a Service can already be acquired at AWS, for example, as well, if you'd rather run all your stuff in AWS, right? So, and I'm sure it's going to happen at Azure and eventually at Google as well, right? So IBM tries to be not bound, so you don't have to be on IBM Cloud to use the technology there. The nice thing about it, by the way, if you're, that's the only thing I'll say about it, is that if you do, right, then, and you have your workloads, and you would have workloads on multiple clouds, right? Let's say you have some stuff on AWS, you have some stuff on IBM Cloud, and some on Azure, and you're running it all in CPDAS, you'll have one overview of everything. Your workloads just happen to run in other places. But it's one a dashboard and everything where everything runs, and that's so from a management point of view, for IT reasons, right? It's quite interesting to look at that. So that's what it drives us. So TM1 itself, for a while, and you've heard me talk about this over the years already, is right. We've been looking at how can we grow to the enterprise effectively and get stuff in there like high availability with failover and scale better for users, scale better for memory usage, and those kind of things of the server, right? Now, a bunch of those we have tackled, and we've, over time a little bit adopted to where and how we'd run them, right? So if you want to scale something for more use, right, you'd be crazy not to containerize stuff and run it in a Kubernetes-based environment, right? That's the whole world is doing this. This is the way software gets delivered in the modern world. So that's what we're doing, right? That's part of the enterprise cloud pack ready, right, portion for TM1. The version I'll be demoing later today is, is a containerized version of TM112, and it is the exact same set of containers no matter where you run it. So if it was locally on your own Kubernetes environment, if it's on an OpenShift environment or a complete cloud pack, or if you run it in any of our clouds that currently has a, again, a Kubernetes environment, it's the exact same set of containers that can be deployed everywhere. It's just the deployment script that will be different and specific to the cloud environment where you'd be running in. So what does it give you? Right, apart from the ease of deployment, right, and then being running in an orchestrated environment where the service itself can interact with the orchestration, and I'll show that later, you get high availability and failover for the generic services that are in there, right? And I'll show a diagram a little bit later as to what's all involved. And with high availability, if you run it in high availability, that means if any component of the whole service goes down, you might not even notice it, because another instance of that same service will just pick it up, and it will just fail over for you, and you wouldn't notice. The other advantage, if you're running TM1 in high availability mode, you can add more nodes. And if you have a lot of users in your system, you can add more nodes just to be able to serve more users. So it's no longer the case that if today with TM111, if you have 2 servers because you want to be, just in case the one falls down, you want to be able to switch over to another, which is an active passive, effectively hot standby. Everything's active now. So if you're running 10 instances, all 10 instances are answering queries from the users, not just one. Right? So by adding resources, by adding more nodes, you can have more users served from the same environment. And we've made sure that all these instances keep in sync. You don't need to do anything. You get that out of the box. You make a change to the model, that change is propagated to all the instances that are running in that environment. Under the covers, we did a whole slew of stuff as well. The new memory allocator, people always want me, or at least internally, they want me to talk about it. At the end of the day, it's not that interesting. The thing to take away from this is that we've replaced how we deal with memory. It should be much better. We're actually giving memory back to the system, which anybody who's worked with TM1 knows that TM1 never did that effectively, or not really well. And I put a note on the bottom right. There's some people that think that because of that, you would need less memory, and that is pertinently not true, because the peak memory usage will remain the peak memory usage, and you'll still need the same peak memory, and therefore the same amount of memory in a node to run TM1, unfortunately. We are doing, this is one of the slides, right? If you saw my last year's slide, you see 1 or 2 things change. And then there's some minor difference. Oh, by the way, on the previous one as well, I'm just gonna call it out. That doesn't work that way. On the bottom left, I have initially deliver focused on Cloud Pak for Data or Cloud Pak as a service. Those 2 that I just mentioned. Last year, I had another comment there, and I implied that there would be a version that you would be able to run just natively on Windows or on Linux. That is not going to be the case. So just as an advance, I'm just going to throw it out there. It's not because it's technically not possible. Actually, I have it running on my machine. But the organization, the strategy, the people that pay the bills at the end of the day have decided that it's not going to happen ever. So just so I see a question coming up. I just wanted to mention it.
Exactly, we directly have a question. So if you say technically it's still possible, you just mentioned it's still possible to drive it locally, so do you think that also heavily users like we are will find out how it's technically possible to still drive it? What do you think?
Well, so it is containerized software. So if you know if you have access to the container registry and you pay for your licenses, right? I don't want to get into that part of the equation, right? Then you can obviously run it wherever you can run a Docker container, right? and I'm more than happy to help you tell you how and where and what. What we as a development team did originally, in the assumption we'd be running as a Windows app, it was effectively an upgrade path that we envisioned. So what we did, we developed a little exe, which under the covers runs the same processes, all the same processes that are running in those containers. And that we won't be delivering, right? But that had failover built in and a bunch of other stuff as well. It was quite nice, actually. But that we won't be delivering. So they don't want us to go there. Oh.
Thank you for the answer. But there's another question I can see. So I will just...
Necessary or...
So the question is actually, is really OpenShift technically needed to run then TM112? So
full disclosure, IBM wants you to run on OpenShift, right? TM112, the service itself, it's a set of Docker containers. It runs in any Kubernetes-based environment. And so I will demo it actually on vanilla Kubernetes and on OpenShift. OpenShift is effectively a different distro of a Kubernetes orchestrated environment with a bunch of extras, but at the end of the day, it is also a Kubernetes environment, right? As there is many out there. So yeah, technically, so long as you have the rights to run it and you have access to the containers, the images, then you could technically run it anywhere.
So it actually means effectively we can still build our own registry, put our own type of containers inside, let's say, and then to run it wherever we want to run it at the end.
Technically, yes.
Technically, yes.
I'm not sure if IBM is going to lock that down license-wise or whatever, right? But technically,
but
yes.
technically, yes. So
Yes.
for all ESA on-prem users, so maybe there will be a solution also in the future. This is what I actually understand.
Yeah. Yes.
Thanks.
So more stuff we're doing, right? MDX maturization, there's actually multiple steps there. We've done quite a bit of work in improving when and how we lazy execute effectively set expressions, which has gotten us to a quite a bit of significant performance improvement in especially more complex MDX expressions. So that's what's coming in the version, the first version of 12. But there's 2 more steps, and I'll get to that later, that we're doing as well on the engine side with that request. Now, moving to the cloud, right? There's a bunch of things you can't do anymore, right? So, for example, you don't have access to the data directory, and a bunch of things will have changed under the covers anyway, right? To counter that, things like execute process, right? Where would you be running? In the local container, there is nothing there, and you don't have access to that, right? So that doesn't really do you much anymore. So instead, we're adding capabilities to do effectively execute web requests. So you can reach out to any service effectively out there, and then the result will be just in a string, right? That's TM1 is relatively basic in that sense, or TI is relatively basic.
Then maybe also when we talk about web requests, I guess everybody would think, okay, it should be some kind of REST APIs we will query, so I guess it will be some kind of JSON coming back. Do you will also enable some kind of JSON parsing support?
Not in the first version. I'm fully with you. The problem is that TI is TI.
So it's not handy with arrays and stuff like this.
No.
So,
Yeah.
But you would also think about that in the future, somehow far future.
I have a point on a later slide.
Okay, thank you very much.
And so to offset, so that's one thing to offset not having access, obviously, to the local environment where you're running your service. The other part is obviously that there is still a need to have certain files uploaded to the server or where the server interacts with. You don't always necessarily want to use a resource externally to do so. So for that, we have opened up, so TM1 in the REST API since 2014 has had content in there, but it was very limited. It was effectively only to expose blobs and the application folders. And so we've opened that up further so that you can now have, you manage effectively a whole set of files are on the server for whatever purposes, right? An application could choose to just dump a whole set of files there. Well, personally, I'm not in favor of doing that necessarily on the server because it's a load on our service and it's load on the disks that we use for the containers under the cover. So a proper content solution typically is better. But for performance reasons, I'll be honest, we've decided to keep this one in because once it's uploaded to our content, we have much faster access to it than externally, typically. Another thing is that ODBC is not something you can typically run easily in a container either, right? First up, it's Linux and not Windows. And then secondly, you don't have access to anything in that container, let alone ODBC sources and ODBC sources that are where? Typically, they are on a customer side, right, somewhere. So for that, we did, in the tradition of TM1, right, and RESTful APIs, I defined a OData compliance specification for a ODBC style, very, very, very simple, right? List the number of row sets that you have, and what's the structure of the row set, and be able to pull the information from the row set by providing a query. But the way it's done, it doesn't need to be ODBC. It can be any data that you can put in a table, effectively. So now you can write services that comply with that same REST API signature and use that to expose data to TM1. So when TM1 now uses an ODBC source, it actually doesn't use an ODBC source. It actually uses an endpoint over the web, wherever it is, wherever you define it has to be, and it consumes the row sets from there. And if they happen to be ODBC, that's fine. If they happen to be anything else, that's perfectly fine too. So that's an extension point for TM1 in 12 as well. Obviously, we provide you an implementation of such a service for ODBC for backwards compatibility, right? And that will still install, actually uses the same technology under the covers, installs on a Windows machine, and then it exposes the data sources that you want exposed as a configuration file for that to the users.
So it effectively means so we can still, in a different way, but we can still use our ODBC sources as we are actually was using before. It's just a different way of obtaining the data and,
Yes.
and getting the data in. But as far as I understood you now, it means we can actually bind every data set that is somehow rows and columns, and if we are able to write our own integration of that, it means we can integrate, let's say, every data. But the thing is, do you know already how this writing of the service will work? Will it be controllable over like the workspace environment, or how do I write it?
No, it has nothing to do with workspace. This is a typical TM1 extension point, right? So TM1, the protocol is specified. We know how obviously to interact with a OData compliant RESTful service, right? Being a OData compliant RESTful service ourselves. So you specify, actually we allow you to specify in the configuration an URL to your service, in which case nothing changes with what you have today. Data source is the data source. We'll use that URL, but you can specify URL as the data source as well, in which case it can be any URL to your service wherever you are running it. As long as the endpoint is the same endpoint as specified by that common schema definition file, then you're good to go.
Okay, so actually I understand. So if there is a common specification, you can directly actually just grab the service knows how the data is structured and can then obtain the data.
Well,
So
you need to code something, but yeah.
yeah, but typically like middlewares, web APIs, stuff like this can provide the data, and we can grab it from there.
And there's libraries out there that help you.
So it means actually the potential goes into everywhere.
Yeah.
So pretty much thank you, because we as OLAPLINE, we provide web APIs and so on in specific ways. So this is a good integration for us. So thank you.
Again, this is a very simple first step, but it's it's an extension point, and more of that later, right?
Thank you.
We're actually doing, and I didn't put it on the slide, we're doing the same thing obviously for CSV files. CSV files can come from, like the web request integration, they can come from our content, so they're still local to the TM1 server. But if you put something like http:// you know, whatever your server is / you know, your favorite CSV file, pull it from somewhere across the world, that's fine too. We'll load that as well. So you know, everything's become resources now instead of local files. That's the way to think about it. So it's opened up in more places, but you know, the list is too long to go into all of them. Touched on these a little bit already, but high level, most important things of what really changes because we're moving to a cloud environment, right, is that we've changed, actually the first one is the one that's not really because of the cloud environment, but we used this opportunity to change our metadata format. Meaning, you don't have access to disks files anymore anyway, so why would you care how they look like to begin with? And so we've based on our Git format, have our own new metadata format. And it's very akin to the REST API as you know it already. Uses the OData 4.1 JSON format and streams those out effectively to disk. The thing is, we in the background use a bare Git repository for this as well. Because all the replicas that we're talking about on the cloud, they share the same VPC, the virtual disk, PVC, sorry, persistent volume claim. And they share that bare repository. So an instance makes a change, makes a commit set, all the commits are ordered, and then all the followers can then pick up changes from there as well and apply them correctly. What this also gives us, we haven't exposed this yet, but for the future, it gives you a full version history of TM1. And you could actually potentially go back to a version in time, something that you've never been able to do in the past. And we're also now able to keep changes to the metadata with changes to the data, which is something that we couldn't do in the past either. The other thing that's going to change is because we're integrating with logs and stuff like that, right, on the cloud, right? So logging in a cloud environment works differently. And so we're integrating with that. That's the high level of what we did there. Okay.
So a client asks, he says a client of him understood that actually TM1 will completely go to the cloud. So we have the answer already. It's not fully cloud, but it means it is containerized, and so you can also drive it locally, but it's containerized. But actually, he asked, so the usual client technology like Architect, TM1 Perspectives, and stuff like this written in C API will be available anymore or not? Oh, cool.
That's the last one on this one here.
Okay,
I'll go there because
slide
transaction logs
is
is where we store
the
them.
answer. So
Yeah, it's REST API only. And that's the decision that's been taken a long time ago, but yeah, REST API only. And this is the first version where it will be only REST API. It's very simple. The nature of the old C API and Java APIs, however smart they might have sounded and felt, everybody knows that over the WAN, the performance wasn't what you won't expect from it necessarily, right? Oh, somebody's phone is ringing. And but the pure nature of those protocols is that you would never be able to route those over the internet. The first proxy would directly dismiss them. Let alone, besides the fact if we could run something there, if you want to go over public internet and ingresses and stuff like that, gateways, they will reject it, right? It's not checkable. And plus, you can't make the protocols highly available. By the sheer nature of how they were constructed, how they were built, and how the reference system was, it would always be one node specifically. So yes, all the old clients are gone. Only REST API-based clients will be there. So, high-level overview. Don't read too much into this. This is a picture that we use internally, but it helps to explain what's going on. So this is a picture where it's actually focused on planning analytics workspace, right? So where TM1, the database engine effectively, is integrated with a offering, in this case planning analytics, right? where Planning Analytics Workspace or Planning Analytics Workspace's ingress server is the entry point into the system, right? And so, so you see 3 bigger blocks here. On the top is where the customers come into the application, right? In this case, Paul. There's obviously a whole slew of stuff on the Paul side, way more boxes than on the TM1 side. And then eventually Paul consumes TM1, right? And then so it comes into TM1 in our gateway. So TM1 itself is no longer one monolith process, but there's actually quite a bunch. Not all of them are in here, but these are the important ones, right? There's a bunch of services, microservices if you wish, under the covers that work coherently together to do whatever it needs to be done based on whatever the REST request is that's being sent to the TM1 server. And the entry point is always a gateway. So the gateway decides as to, what is this type of request? Do I accept this request to begin with, and then continue, right? So is this a request authenticator? No, it isn't. Then it has to go to the authorization service first, right? If it is this a batch request? Is this an asynchronous request? Because then, if it's a batch request, there's all kinds of stuff we need to do with scheduling, execution, and stuff like that. If it's an asynchronous request, then we actually have to be prepared to store the result until the user comes back and asks for the result and those kind of things. So that's all the logic and the lines that you see up there, how that orchestration goes. And then there is a TM1 daemon on the right-hand side in that bigger box. That's the one, until there you haven't touched the TM1 database yet. This top part of the infrastructure is what's always running. That's what we call the TM1 service. That's what gives you the feeling that TM1 exists on a cloud environment when it's spun up. But there ain't no databases. And a database in this context is what you perceive today as a server, right? One database is one server. But this environment is able to run many, many instances and many, many databases in every instance. We only have to spin up one of these to deal with, as long as you have enough resources and computers in your cloud environment, you can go wild and ask it to create more services and scale it up and do whatever you want. And on the bottom there is these 2 databases, right? And 2 databases, we call these individual instances replicas. And you can have one. If you start one, you'll have one. But you can choose to scale one up or one down, depending on your needs, as I talked about before. And as soon as you have more than one, effectively, you're running in a highly available mode. Because if one goes away or crashes or whatever would happen, the other one will, deal with all the requests.
Got another question?
Yeah.
So actually from outside this question is coming, when the TM1 server was driven, usually everybody also here in the room maybe was using some kind of very easy backup method. That means I just make a backup of the disk, so if something happens I can just go one day backwards. So if we now think on Git integration, it's the only way actually to get into the really, let's say, files, photos, however. So how would you deal then with backups to get them in and out, let's say?
That's a big assumption, by the way. It's not Git integration is the only thing. Actually, they're 2 completely separate things. To me, Git integration is for source control and source management. It has nothing to do with backups or even running the system. On the other side, we have a Git repository. We're just using the same technology. Those 2 things even don't have anything to do with each other. And the way they store it and what you would store is actually different between these 2, because one is source. How do I build my model from information that I have? Right, and the whole description around it and a project file and stuff like that, whereas the other one, the bare Git repository that we use under the covers is the materialized version of the model, right? We just happen to use a Git repository to be able to keep track of versions and to know what the history is and stuff like that, and to be able to share that with multiple nodes, right? They're different. Separate from that, we have a backup and restore capability. And I'm actually planning to demo that later on, because I'm going to fake that I'm actually moving to a completely different cloud cluster later on, using a backup and a restore.
So it actually, for me now, I understand I can automate somehow then this backup, like do it every night.
Very easy. Very easy. Very, very easy.
Very easy.
Very easy.
Okay, then this will be the answer. Thank you very much.
I'll demo that. Yep.
no authentication in TM1 anymore. You need PAW for authentication, no native authentication.
So I guess the
I don't
question.
think that's a question, that's a comment.
Yeah,
right?
or more or less, I guess the question.
No, what Christoph is referring to is that in this setup, right, and actually I have that explicitly marked in my demo as well. In this setup, it is indeed PAW's responsibility to authenticate the user, right? And so we trust the application, in this case, in this picture, it's PAW. Could be other applications as well, I'll show that later on. But we trust PAW to, when it connects us and asks us for a session for a user, that it did authentication already. And in a cloud environment, it works that way because if you weren't authenticated, you wouldn't have gotten into the system in the first place. So TM1 doesn't need to validate that authentication again. You wouldn't have gotten there in the first place if the user wasn't authenticated already.
But it actually, for me, I understand that the native authentication, like we know it in the basic, just the TM1 server authentication,
It's gone. Yeah, well,
it has gone. It's not possible anymore. So it means you need to somehow via PAW, or can we then implement our own some kind of application that will allow this authentication to inside?
Absolutely.
Absolutely.
So this is the cool thing, right? So the service, right? If you have the rights in your environment, in that environment that you're running the server in, to create instances and to create databases, then you can trust an application to come in, and then that application give me any usernames, and we don't care who authenticated it, where authenticated, if they're even authenticated. Now, obviously, that's your responsibility then, because you will have to have root credentials to be able to do that.
Okay.
But if you have root credential, you're God in the system, you can set it up in a way that there's no authentication to begin with.
So it would be actually
Or invent your own authentication scheme.
be possible without authentication at all, then it says. But another question was actually coming in. So how to route REST API requests to the server at all? So the user understands outside that actually you need PAW in front of to route REST requests to the TM1 server itself. But actually, from the architecture, as I understood,
That sounds like a lean TM1 question.
Ye-
It's the,
I guess it's a lean TM1 question.
again, TM1 itself, right, has no limitations there. So if you set up an ingress server that allows direct access to the service, you have direct access to the service. It's that simple, right? Now, in IBM Cloud, at least initially, the only ingress that will be exposed on public internet will be PAW's ingress server. So yes, you'll have to do PAW and then use the PAW proxy effectively. It's quite direct, but there is an extra hop in between. Yeah.
It means actually if I build my own way of how I route the traffic inside, so actually it will be still possible to somehow do it.
There's no
bit
technical
indirectly, but-
there's no technical limitation, and the rest you have to work out with IBM sales and legal.
Okay, understand. So it's a more or less like also license thing then at the end.
It's this design is obviously highly driven by the fact that how IBM wants to expose applications and stuff on cloud infrastructure and what our main goals are. But as I'm sure people know, right, there is still people and partners out there that can still sell separate TM1 license, even though officially TM1 as a separate product hasn't existed for the last 7 years or something like that, right? But the licenses still exist, right? So it's again, what we officially publish and say that we have available versus what really technically is possible if you negotiate is two different things. Again, I'm a techie. I'm never ever involved with any of those things. I'm just telling you that technically there is no reason why you couldn't, right? If IBM allows you to do that, that's a different thing.
Okay. Thank you.
So, TM1 12, you mean? No, it would be the same thing. You have CP4D, right? A CP4D installation. In CP4D, there would be a planning analytics tile. And that sets up the whole infrastructure, and after you've done that once, and probably paid a bill to IBM or whatever, and then you have access to that, to planning analytics, which includes TM1. So you're going again. Your authentication on CP4D, by the way, is CP4D identity and access management, right? And so you're logged into CP4D to begin with, to get anywhere in CPD, and that's who you are. And then obviously that's then used that's passed on effectively to TM1 as who the user is.
Another question, will element security still exist?
Yes.
Also cube dimensions?
Yes. Yes. Yeah, that's not changing.
Sorry, we just have to repeat the question via microphone because otherwise
Okay.
we don't hear it. So the question was, or does element security, cube security, even down to cell security and other security, will it still exist actually?
Absolutely. Yeah, so effectively, the TM1 database in this environment is still the TM1 server of today. How you get there is a different thing, and the management of stuff, et cetera, and who starts the thing, stops the thing, scales it, is completely different, and the synchronization we take care of, et cetera. But the core TM1 server is still the same. No change. Security layers are all the same as well.
We have a question now from one here out of the room.
No, it's
So we have heard that the TM1 security will still be in place. My question is, will it be same the exact idea, or will it still work the same, or in a different way? My question is, especially when we use more MDX, stack dimensions, whatsoever, and today when we are have security over C elements, you see all elements below. So if you have a C element with a read-write, you see the full sum of everything below.
Yeah.
But does it still work with MDX? Also with a full MDX
It's
view? In that
logically,
case.
there's no difference between those.
So that means actually we understand still it will be the same way. Actually, the C element sums up all elements that are under it. No.
Yeah, how the model works is absolutely not changing at all.
Okay, so that's
That's
the
exactly
same.
the
And
same.
also when I grab it via MDX, so I will get the same results as today actually.
Same as it is
Yeah,
today.
so like security-based aggregations will not happen, let's say.
Let's hope not. I'll quit if anybody puts that into the
Yeah,
product.
I know we understand that it would be a huge effort.
It's not an effort thing. I think it's wrong.
Yeah. Okay.
It's like, I've used this example before, right? The Benelux is the Netherlands, Belgium, and Luxembourg, right? If I have a geography dimension and I have a C element Benelux, which I have defined as being Netherlands, Belgium, and Luxembourg, and somebody has no access to one of those countries, are you redefining what Benelux is? Then it's Belux or Nebbe or one, but it's not Benelux then in that case, right? So you define what Benelux is. The thing is that a lot of customers actually use it in a way that that the user can only see the C elements and not the detail underneath it. In this, if you do security-based aggregation, then everything would be empty because you can't see the detail, right? It makes no sense either. So the model is the model. If you need a different way of doing it, that's visual totals or something like that, right? MDX has a function for that, and that works in TM1 too. That's fine, right? But at the core, the model is the model, and if you define that Benelux is the aggregation of Netherlands, Belgium, and Luxembourg, then it is the aggregation of Netherlands, Belgium, and Luxembourg for everybody, right? That's a concept. It's nothing to do with how much work on it. That's a conceptual thing. If you break that, you break everything.
Just
That mathematically doesn't compute in my head.
Yeah.
That's why I'm saying I'm
So the rule is actually just security needs to follow the structure, or you have to build a structure like the security you wanted actually. Otherwise, it's not possible. I guess
the security just tells you what you have access on, and be careful, right? With even rules, right? Rules have access to everything, right? It's just what you associate the rule with, you can secure, not the rule itself. The rule again has access to everything.
the last winner question now is actually when will be let's say how he asked it, like when we will be able to get a hands-on Docker image of TM112.
I've got one.
You got one, yes. I would like
But,
to have it.
I'll be fired if I give it to you, but no, I don't know the details. There is going to be a beta of 12. I think the target date currently is, I'm saying this wrong. There's going to be a beta of the next version of Planning Analytics in this shape by the end of October. 29th, I think, is the target date. But that's one that is only available on IBM Cloud on CPDAS.
So I have read
So it means 2029, yeah. Okay.
October 29th beta,
Okay.
which means you have to be in the program, know somebody at IBM is going to put your IBM ID on the list, and then you then see a beta tile for Planning Analytics, and then you can install an instance of Planning Analytics, which obviously has everything and TM1 and everything underneath it, and then you can play with it, play with everything Planning Analytics, including TM1 under the covers, and the REST API if you want to do.
Please go on.
Yeah? All right, so again, high-level picture, replicas, a database, individual databases, as I have two in the bottom, one with 2 replicas, the other one 3 replicas, share a volume. We've put NFS here, that's a technical thing, because it needed to be an NFS volume in IBM Cloud speak, because that has to do with the type of persistent volume claim, because not all will be persistent enough or secure enough for failover purposes. And then to the outside world, there's a bunch of things, right? So we are using a MongoDB database to coordinate stuff and to keep track of stuff, especially around transactions that are being done on the server. LogDNA is in IBM, the place where all our logs are being collected. And so they are collected from everything that's part of the IBM. But in LogDNA itself, all these services will effectively contribute to TM1 log. So it's not like you have to go, I shouldn't badmouth anything, but like in Planning Analytics, you have to know which service it came from because the log will look differently. This is just one harmonious TM1 log. It doesn't matter from which service it came. You'll be able to deduce from which it came, but it doesn't matter from which it came. 6 digits for management internally, and then on the other side, right, you have, it's a Kubernetes environment, right? So you're running in a Kubernetes environment and you can, everything that's there. IBM's identity and access management is what you need to log into IBM. That's what you use your IBM ID. That's how you're known in the system, and that's where, it comes from there. And then the ODB CIS is the ODB, which I mentioned on the previous slide, right? This one, right? So it's external to the service because the customer needs to install it somewhere where he or she has the ODBC sources, right? And we just reach out to that. And with the web request, right, you can go to effectively any external endpoint. HTTP-based at the moment is the only limitation for that. So that's the bigger picture, and then if you're really interested, we can tell you, the type of VPCs, if it's TLS, mutual TLS, or what type of connections and stuff like that. That's
And another question comes in: are those logging databases queryable, or will it be queryable by the TM1 REST API at the end, or is it different API? Let's say.
In a cloud environment, all services that run in a cloud environment contribute to the same log mechanism effectively, right? So people that are used to running a Kubernetes environment or a cloud environment already have a dashboard in which they look at logs, which they use to filter stuff, right? So LogDNA comes with that option, right? And if you type in some keywords, then it immediately zooms down to whatever you're specifically looking at. So we didn't want to add anything there. So while the endpoint for the message log still exists in TM112 because we didn't change version number of the REST API, it doesn't return anything. You have to go to the logging mechanism that is applicable for your cloud. And we support LogDNA out of the box. We support ELK. And we support Logstash, and we support just collecting of file-based control output, which is standard supported and collected in a Kubernetes environment as well. So all of those are there. And then it's up to you to do that. The logs, by the way, are changing anyway, right? So you can imagine that we're overhauling all that stuff, what's being logged and stuff like that. There's a whole slew of logging stuff that was in there that's no longer applicable because we don't support the old APIs. The granularity changed, and et cetera, et cetera. So that's still in flux. So I have no clue what the time is and how much time I spend already, just to see how I have to.
11:56.
Okay, I have to speed up.
half an hour, so I will filter the questions now.
Okay, keep going. So I introduced, actually it's based on other guy's demo, Pony Music last year already. Last year I went in and I created a Git model for it, and did all the Git integration and used that to explain it. Now that Git model I still have in a repository. We're going to take it further now. Now we're going to take it to the cloud and deploy our model on the cloud based on that. Scale it if it works. This morning I had some issues. They deployed a new version yesterday internally. It's still alpha state, right? So I had a little hiccup this morning. And then so I'll deploy it. I'll show the high level of it. I'll do backup and restore for disaster recovery. I'll try and look, and as part of that, you'll see a little bit about what I meant with loading files and stuff like that, and content as well. So let's see how far we get. This is where the technical stuff happens. So for starters, I'll go to. I hope everybody can see my screen, and the Wi-Fi stays up. Afraid the IBM cloud was down. That would be bad. Well, you never know. Facebook was down earlier this week. So this is my entrance. My account, or PaaS dev. That's TM1 and PA developers share this account, and we can do stuff here. But the clusters that I have available to myself on this cloud environment is specifically two. The top one, Exciter Dev, is a standard vanilla Kubernetes environment, which we're running the IBM Kubernetes service, IKS. And so the vanilla Kubernetes, and then I have a TM1 Dev OS, which stands for Development OpenShift. So that's an OpenShift environment. They're, other than that, effectively equivalent to each other. So I'll start with IKS. I'll show in a second, but I use the IKS version, so the vanilla Kubernetes, as my development environment, and my OpenShift one as the production environment. You'll see it in a bit.
In a bit into the browser, just a little bit to make it a bit bigger. I guess it's better readable.
Let's see. I have a challenge there when we get into the request, right? So So I'll open up the Kubernetes dashboard because this is just a high level on the cloud about the cluster. But anybody who's ever done anything with vanilla Kubernetes will know this. This is the dashboard in which everything exists, right? And in this dashboard, I can show you already. Let's go to pods quickly. Oh, I have to obviously choose my right project or namespace, as it's called in vanilla. So it shows me quickly, CPUs, memory, all kinds of stuff, right? But what's interesting is the pods that are running. And on this list, there's no database yet, there's no instances yet here. It's just TM1 service is deployed, right? It is available for you if you needed it. It's not running anything yet. And what you see is TM1 daemon 0, TM1 daemon 1 and 2, I'm guessing, and gateway 0, 1 and 2, and then you see authorization and async handler and stuff like that. Long story short, these microservices, based on the current load, and we use 3 instances as the minimum, right, for high availability. We deploy these services these make up the base service, right, so that TM1 is available to begin with. I'll get back to this as soon as I'm adding database, but this is the high level. When TM1 got deployed as a service in here, it also installed a couple of things. And again, I'm God in this system, right? I have full admin rights. I can do everything here. So I can also see things like secrets, which are very well protected otherwise in this environment. And what's interesting here is, which I'm going to use here shortly, is this thing, which you will have to have, is the client ID and the client secret. These two things are, this is, how God gets into the system and can do stuff. And I've copied these in my configuration file so that in the REST API I can use these in a second as well. These only allow me access to the management portion of the service, nothing else, right? If I want to do something else, I have to be an authenticated user, have a session, stuff like that. I'll show it in a minute as well. But just want to show, these are generated by the system when the service get deployed. If I would throw the service away and redeploy, I will never ever get this set. Well, the chance of getting this set back is like 1 in a million light years or something like that, right? It's not going to happen. So they're very, very unique. And that's everything effectively to bootstrap stuff. And now for the really technical stuff, I'm going to switch to my Visual Studio environment. This is small too, but I'm not even sure how easily I can make this bigger. Yeah, there's no such thing as a zoom, but I think you can set the, oh, there was a way. One sec. Preferences, settings. I think I can do, that's better already, right? Well, if I do it too big, then I keep scrolling all the time and you don't see anything else. On the left, you see, I've prepared obviously a demo. On the right, you see the responses from the server. So I hope you're a little bit familiar with the REST API, because otherwise it's going to be a little bit drag. The only other thing you need to know is that I created a settings file. This is something I can do in this environment, so to know what you're using. So I'm going to create a database name, which I call Anwendertreffen demo. I'm using my repository from the Pony music model, right, which you can actually go to. I think I can actually open it up. So that's just a repository on GitHub, public GitHub. By the way, the two clusters I'm using, the IKS cluster and the OpenShift cluster, are actually running in Montreal, which is single node data center. So it's halfway across the world, just to, some things are actually quite nice and fast, some things are different, so just show. So this has a source, I won't go into this, but if you, the definition of files, right, I'll quickly show you, right, the record, it has, which dimensions are in there, and then links to stuff, and then even the rules of a database are obviously in code here, right? You can all see this and do whatever you want to do. Same thing for dimensions, right? I think the nicest example was the stores, store hierarchies. If I take store, right, it has all the elements in there, all the in code. The same thing as if you would pull them through the REST API, right? But this is the code for it. So that's there. I created that 12 months ago, still there. I'm going to use that. Let me go, by the way, back here to the pods. Yeah. Set things up. I just removed my password. I noticed a couple of months ago that somewhere in documentation and somewhere in a video there was in clear text my password for GitHub, so that's not a good thing. So I changed that and removed it now. So these are the two entry points. So Exciter, this is the host for my IKS cluster, and you saw these names just now, right, as the cluster names, right? Exciter Dev and TM1 Dev OS, and they're running in Montreal 1, which is the data center, and then .containers.app domain, which is where I'm running the stuff in. Those credentials I quickly showed you, the client ID and the client secret, that's this, that's this one and this one, right? So I copied those here so I can use them, etc., and a couple of other things. I'll get back to the other ones. So to go back to the actual example, so I refer to these between these brackets. That's just how this works. So just to start at the highest level, I'm using the root credentials, right? The root credentials are effectively basic, and then the client ID, client secret that I just showed, base64 encoded when they go over the wire, right? And then I'll pull the metadata for it. You see, it's halfway across the world, but it's not slow or anything. But at the highest level, there is not that much, right? There's these includes. I have to scroll more now, but it defines things like an application, an instance, and then that's pretty much it. It has a collection of instances. That's at the highest level. So let's look at those instances, right? So currently, I have only one instance somebody created, and one of the guys works on my team. So I'll create a new instance by posting to it, and I have those root credentials. I allowed to do that, and I created a new instance called OLAPLINE-TM1. So I've got now an instance of the TM1 servers on IBM Cloud running in the Montreal data center, which is called OLAPLINE-TM1. There you have it already. You can start beta testing. And then I can, obviously, since I newly created it, there are no applications. So applications is this concept of, who do I trust to connect to my system? I don't want to give those root credentials away that I just had, right? That ID and secret, I want to keep close to myself. There's only 1 or 2 people that probably will have it. And you want to keep this actually in the cluster, right? So what you do instead is you create an application that you trust. In this case, I'm going to create an application called OLAPLINE-Anwendertreffen. And so I'll send that. And then you see I get a client ID and a client secret. Again, these are just as unique, gazillion light years. You might get a chance to recreate the same thing. Very, very hard. The secret, this is the only time you see that secret. So when you create it, it's returned. Because this is the time. Now I know I'm in there with root credentials. I have to copy these now. The client ID I can continuously see, but the secret I can't. So I copy these to my application ID and secret. And these two are what I need in a bit to create a session for a user, right? So applications, so you trust an application given a certain ID. The ID is OLAPLINE-Anwendertreffen here. And, and that application is allowed to log in to TM1 and ask for a session on behalf of a user. That's effectively the trust you now give to an application. In a typical PAW instance, you would see an application called PAW. And then PAW stores those credentials, that ID and that secret again, because it's running in the same cluster, as a secret in the cluster as well. So that only when you have the right access rights in the system, right, at the highest level, then and only then you can see that secret, so that you can connect to TM1 and create that session.
Just a detailed question is, and how I then, okay, I have now the credentials to somehow have the root authentication to my application somehow, and to authenticate, but how then I map it to the, like, we have the client dimension in TM1, and how it...
Yeah, this is not client dimension, not related at all, right?
Not at all, but how later I can then map users actually and authenticate them.
Same as it used to be. Hold on, give me 1 second. Let me create a database first, and then I'll answer that.
Okay, thank you.
Right. So the next thing we need to do is, right, we don't have databases yet, right? So it's an empty list of database. So I'm going to create a database with a database name Anwendertaak-demo, right? Which is one of those variables I created. So this is the only request that I have to do, and then talk for like 2 to 3 minutes. And the reason for that is because now in the background, what it's going to do is actually going to create that persistent volume claim. And that takes time. At least on IBM Cloud, it takes about 2 to 3 minutes. But in the meantime, we can actually look back at this list. And you see now that at the top, there is a new TM1-I, that ID you'll see shortly as well, because everything up to the -0- part is the ID for the database. And then the 0 is the identification of the first replica of that. So that one's pending, and it will take about 2 minutes, the first one, because we are now asking Kubernetes to ask the cluster to create a persistent volume claim and then make that exclusively available for us. What I didn't, and what that volume claim looks like is actually what I specified here. I asked it for a 20 gigabytes persistent volume claim. For demo purposes, 20 gigabytes is enough. You can imagine you need something more in certain cases. And the same thing, is these kind of requests and limits, right? So what you request and what the limits are. So CPU-wise, 100M is 1/10 of a processor, logically, and that has to do with scaling. That's how this works in these Kubernetes environments. And the maximum amount of CPU I'm going to use is one CPU, 1000M. That's one CPU. But one CPU doesn't mean I can run one thread. I can be running 100 threads. It's just that if the cluster has to throttle stuff, then I'll get, if it's 100 threads, I get 100s on 100 cores, effectively. That's what happens then, right? It does the throttling for you. And you can, and then eventually that defines, those limits that you set up here defines the bill at the end of the month as well, right? How much you can change these dynamically. So you can, if you say, I've got a big planning cycle coming up, right? You can change the number of replicas you want, the CPU on these replicas. You can, the CPU limits, the memory limits, and everything. You can scale it up if you need it to. Don't make them too much if you don't need them immediately, because especially on the memory side, because the cluster is going to, for the extreme scenarios, it's kind of allocate, what's the worst case scenario that I need, and it's going to use those limit values as the worst case calculation. Again, this is Kubernetes stuff, has nothing to do with TM1, right? All these things. These are just passed on into a Helm chart that's given to TM1, and then, to Kubernetes, and Kubernetes then deploys the service in the cluster the way you've asked it. And I've done my best, and now you see that the request came back, and I've got one active replica. It is ready, and this is the version tag at the moment. And you see, here it repeats those limits that I got, but I can patch those later if I wanted to. And there's only one replica at the moment. So I've got a completely empty database now. And to show that, I'm going to go forward. Oh no, the first thing I was going to answer your question. So using that application client ID and application client secret, I'm going to now call a authentication endpoint. And this is following the OpenID standard, right, which we're going to fully support at some point as well. And so the only thing I need to do is, instead of a JWT, we allow, since this is a trusted application, we allow you to just specify the user. Whatever is the unique identification for this user. It could be a GUID, whatever. This is the thing that's going to be the client element in your client dimension, right? That's what it maps up to.
Just means with that ID, I am logged into the TM1 server, so the element security and stuff like this will work then over the user.
There's a client that is, in this case, my email address, right? And then whatever groups that client is in, like it was before.
So
yes,
before,
absolutely.
Thank you.
And so if I send this request, you'll see. That is interesting. Yeah. Okay.
So it was just a copy-paste error, it seems. So
Copy-paste there. Yeah. Okay. No
so
worries. But as I said, I can't do that. It was just the client ID or the secret? Okay. Then we're in luck, because then I can grab the. Otherwise, I would just have deleted it and recreate it. It's fine. Let's see. Where are my instances? Oh, my applications. Because the client ID I can copy.
Delete the rest. See it like that was from the old one.
Thank you. Wow, you guys are good. So let's try this again. Go to my send request. Perfect. See, and now, same as before, if you use the REST API before, you get a set cookie with a TM1 session ID. That is the session ID for the authenticated session for me. The only difference is because the infrastructure is different. The infrastructure implicitly, the ID is a little bit longer now. It's a JWT token, and it has the domain in there. In this case, I'm using my Exciter dev cluster, and that's, the in the URL, the host that this works for at that path. So now I don't need any authentication headers or anything like that anymore. I can start looking at the service itself. Now, we decided, and we contemplated this a couple of times, to not change the API version number for TM112. I was planning to do a complete new version of a newer version, which we cleaned up a lot of stuff, and we learned obviously over the last 7-8 years as to how things could be better. But there was a little bit of peer pressure from our planning analytics friends that didn't want to change any code, and they wanted to continue using V1, and so we were forced to do that, which has a consequence for the design of the REST API, because the root of the service has to remain the same, which means the REST API from TM111 effectively is the REST API for the database portion, not the management portion or anything on top of that. And now I'm dealing with many databases. So what we did is effectively service composition. It is something that SAP and Microsoft do all over the place using OData services as well, where we'll have a little service that then has a URL again, reference to another service, and from which you then repeatedly get the metadata and you can dive into. At the end of the day, for most consumers, it doesn't matter that much, but by looking at it, it might sound a little bit strange that you grab metadata at multiple places. If we move to a version 2 later on, it'll be the whole service, and then it's just one again, but that's for now. The reason I'm saying that is because I introduced TM1S here, versus the old one is TM1. So this is the service level API, which effectively only has things to deal with the database itself, like backup, restore, migrate, update, and then a couple, I think. Sources. Yeah, I won't go in. I'll get to backup and restore later. Those are the things that are described there. So restore is one of those actions that is there. Backup is one of those actions that are there. And obviously the sessions, again, at the service level. Again, I'm talking about the service now, which I have multiple databases in, right? Not one database like one TM1 server in the past. I can have multiple ones. So again, there is only one database that I just created. So also if as a user I go in, I see that one database. And I wanted to quickly look at the cubes that are in there. And I'm filtering so I don't have system cubes in there, right? Because they're always there. So there's currently no cubes, right? So now I'm going to, and I'm just quickly stepping through this because I've done this before. I'm going to use git init to set up the link to my GitHub repository, right, which I showed before. I'll create a pull plan and I'll execute it. The pull plan creation, stuff like that, is actually faster than local if I run this on cloud, which amazed me. Or at least in TM112 is faster than TM111, which amazed me. And now the whole service the whole model is now running on cloud. And if I now send that same cubes request, it's showing me that there is, I think, 5 cubes, record price, record rating, record sales. It's all there with the respective dimensions and everything. So the whole model got pulled from the source for the model got pulled, it got executed, manifested, everything's there, right? Now, unlike last year, I'm not going to consume the model, but that's there. So to go quickly back, right, I have this one pod here on the top, which represents this one database. Now, I'm going to try this. I might have to backtrack a little bit. So if I want to know, scale this, have multiple instances running, the only thing I need to do is patch the number of replicas of that database. So if I send this request, in the past, you wouldn't know what you would need to do, right? This would be, a big project, a couple of months work, you have to do all the synchronization, stuff like that. Whereas here, 2 seconds later, not even 2 seconds later, we've already spoken to the Kubernetes environment, to the cluster. The cluster has started 2 new pods. The pods are starting up the container images that need to be in there for the replicas. Then there is a leader election, which is very simple. There was one, so that's the leader. The other two will be followers. They look at what version the leader is on. They'll load the database, make sure that they're up to date with the same version, and then it'll come back. It'll take about a minute in this particular case.
So actively, it means all the synchronization stuff, no matter how we did it in the past, it's actually just gone. You don't need it anymore. So no, I don't know, middlewares transferring between or whatever. It's everything not needed anymore usually.
Not for a single instance, right? If you still have development, test environment, production environment, that's a different thing. That's where Git integration comes in and out. Or you might take a backup and restore it. But typically that would be more a source, oriented scenario in how you develop and progress stuff to the system. But for individual instances, if you're running these at scale, right, where people did all kinds of tricks, and I helped them with the transaction log APIs and with allowing you to manage your own TM1S, in the admin host, your list of services, stuff like that. Stuff you don't need to do anymore. That's all. This is like years better than anything we've ever had in the server.
Just an additional question: now we have like 3 replicas, let's say, what does actually happen if I start something that is locking, not logging, locking?
Yeah.
A full instance that we know it before. So we know, okay, you have a server, it's running one instance, and you make a request, and actually, boom, nobody can do anything anymore because you're making something with the client dimension, you're making something with strange things.
Yep.
So actively, how does it work then here in that replica scenario?
Well, as I said before, the server, the database instance service, the replica, effectively is the old server, but just the database portion, right? Changes made in those kind of cases and running of TIs, for example, always goes to the leader of the pack, right? So it would always, in this case, go to this one because I know this is currently the leader, right? And so if you run 2 processes that would have a lock conflict, they will still have a lock conflict. Nothing changes. And that's perfectly fine, because locking is not a bad thing.
It needs to happen sometimes, it's of course.
So two-phase commit is, two-phase locking, two-phase commit locking is a pattern that is used by thousands and thousands of database systems in the world, right? And we use it too. There's only, there's nothing wrong with the locking, there's only something wrong with users of the locking, right? So people that, deliberately have no control over what happens in the system, or, just run stuff and they know it's locking anyway, then you're asking for it, kind of. But no change there. It's exactly the same as it was before. Now, I am afraid, because this one didn't come back, so I'll go back to my database.
Another question?
Yeah, one second.
Will there be an update to the security mechanism so some server metadata like version config can be read without admin rights? Like admin with read only?
Sorry, once again,
I guess the question is more or less like we have some parts of the endpoint, like get the configuration of the instance like before in the REST API, and all is protected. That means you need to authenticate first to get configuration version and stuff like this. Will there be maybe in the future some update so you could, okay.
No, it's actually worse. You have to do anything with the service, you either have root credentials, application levels credentials, or a session. That's it. You're not getting anything. And again, in a cloud environment, right? Before you get into the cloud environment, you're already logged on. We know who you are already. So it's up to the application that connects TM1 to make sure that it passes that on. But it's transient, so it shouldn't. It's different in that respect. It is different than running it standalone, right? Where you think it's a hassle, I have to do this on top and stuff like that, right? This all happened already, right? The authentication has already happened, right? The only thing is you have to pass it on to TM1. Yeah, and if you're not officially a user, then if your admin feels that you shouldn't have access to that database, then what the hell are you doing questioning that information anyway?
But actively, it means if I write my own kind of microservice using the client's secret or the secret provided, then I could actually query all this configuration stuff and give it also to outside for no authentication if I build it like that.
Yeah,
So-
if you portray my trust, then that's a different thing, right? And that's not my problem, that's the problem of the administrator.
Of the administrator
cluster.
that would allow to then give some specific endpoint outside, and then you could query it.
Yeah.
Okay, thank you.
All right, so I'm going to admit, damn it, yeah, last night worked. So we have an issue in the system. This takes forever. This should have just taken 40 to 60 seconds, and we saw it twice yesterday already as well, where we updated the cluster, both clusters yesterday. So there is an issue now in this version that, for some reason, I've been told it works, but it works like dog slow for some reason, and we don't know why. So this has to be fixed. So I have to go back. I'm going to quickly delete this database, because I can still delete the database. It might take a couple of seconds, but it's going to tell me that it's deleting the database. There it is. The command went through, and what the? I forget what's happening on top, but you see here these top 3 pods now that were the replicas of the database. I just issued the delete command. You see they're terminating, right? So we told Kubernetes we don't need those anymore, and it's tearing them down. So and they'll be gone in a second. So I can go back now, and immediately, and I'm going to sift through this very quickly. So I'm going to recreate that database, which is what took a couple of minutes before. And when I do that, you'll immediately see that there's a new one pending here. So one of the 3 terminating is already gone, and a new one is here, it's pending. You already see that this has a slightly different ID. So we'll have to give this, again, the 2 to 3 minutes, and it'll have a new one up. And I won't try to scale it. But the scaling part is, so I changed that replica number. You see it actually creates the pods. For some reason, there's an issue now that it doesn't actually come all up. At that point, once they're there, all 3 are there, then the change requests go still to the leader, but queries and stuff like that go to any of the 3, right? It's load balanced across those. That's why I said before, if you scale to more replicas, you can have more users in the system that are firing queries, because we'll just scale that to more nodes in running the database. You can also scale down, right? So it's not that, so again, if you have a application that is, or a database that's used, a planning model that you're using two weeks a month or 1 week a month, and then, we've got one big customer that has a huge model that is, it's every month the same. It's like 8 to 10 days is the planning cycle, and then there's a couple of days low, and then they have a reporting model that is being consumed for like 2 weeks, and then that goes down, and then everybody goes to the planning model again. And these are 12 gigabyte machines, right? So you don't want to have those lying around for the whole month necessarily if you don't need them. So they'll scale up. They would scale up for that period of time, right? And once the cycle is done, scale down for the rest of the month. It's still available, the model, right? And then scale up the reporting model as soon as the data gets loaded in there for that month's reporting cycle. And then until those 2 weeks are done, and then switch back to the first one again. And just keep it around. And you can obviously, because all is REST API based, you can automate this and schedule this and do whatever you want.
So you don't have the local configuration issues, let's say, like you usually have, and assigning their CPUs, assigning there, and so on. It's actually all gone. I just scale it up, scale it down, and that's it.
Yeah, like you orchestrate any other service in your cloud environment. Here it is, it's back up. So I've got it on there again. I'm going to quickly sift through the setting the cookie. I'm going to do the git init. Where's my git init? Git init. Create a pool plan. I love it that this is fast on the...
Hubert, there's another question from Christoph Hein. He asks actually, to read the config at the end, the user must be in the admin group, ? And also try to consider how he means that.
You have to be an admin to look at
the configuration level.
Not 100% sure. By the way, there's a bunch of things that is changing anyway, so a bunch of things that are... there's a whole slew of configuration options that are gone in 12. They're still in the REST API because we can't take anything away. That would be a breaking change. They'll just be null. They simply have no meaning anymore in 12, right? Anything related with the authentication methods, anything related with the C API, anything with throttling and message ports and stuff like that, it's all gone, right? They have no meaning in TM1 anymore. And then there's a bunch of things that are replaced because you're configuring in a cloud environment. So those would be in the configuration maps that you have in a Kubernetes environment, because that's how you configure services. And then there are the TM1 specific configurations, and those are still in there where they used to be.
We're running a bit out of time.
Yep.
Our plan also for the local food here. So they say, okay, another 5 minutes and the food will be ready for
5 minutes, okay.
Yeah.
So,
Thank you.
I did do this. Let me quickly check. I should have my cubes again. Yeah. So I'm going to quickly go to the last thing then, because it was asked before I had more stuff. But backup and restore, right? So what I want to do is now I have created this model with the 4 cubes and some dimensions, right? So backing up the model here is as simple as sending this request here, a post with the backup, and then a URL. Now I won't go into too much details. If you just specify a name, it's actually going to be a entry in our content store, so you can retrieve it later. If you specify a HTTP endpoint, a resource, it'll put it there, whatever that is. And we're going to support MinIO and S3 storage, so cloud storage as well at some point. Not in the current version, but that's the plan. So if I do this, that's it. It's done already. Backup is there for this little model. And so it gives you actually the URL in this case, nevertheless. So I asked it for a backup set, but it stored it in contents, which is something that's always been in the REST API. But we have a new full root folder, which is called files. And that's for the consumer. And following standards, for typical operator file systems, we allow you to have hidden folders, which start with a dot. And so we define a couple of those, and one of them is backup sets. And that now has the backup set 1, which is the name I gave it, right? That I asked here. Now, if I then use the regular, I'm actually going to refer to the header that's in there. For some reason, it got double URL encoded. Forget that for a second. But I can just ask for it. So I see this backup set is 931K-ish in size, right? And I can just pull that one as well. Now, this is going to look ugly for a second, and it's going to take way longer than you think it should take, and that's because Visual Studio is now trying to display 931 kilobytes of data, but it will. There it is. And then I can use this button to say save body. So I'm now going to quickly go to my so what I'm doing, so the first step created that backup set, but in the content, because I didn't give it a URL, right? But that's still on the persistent volume claim of this model. So if this model on the cloud goes down, disaster happens, I lose my backup set too. So you have to store that backup set somewhere where you can use it after a disaster happens, right? So I'm going to backup sets, and I'm going to call this Pony Music. That's the one I want to use. Oh, I have one already. Okay, I'll override it. Save. Yes. Now, just to show that if you really, really want to, I probably shouldn't. This is a TGZ file, right? So if you open it up with 7-zip, for example, right? It's a tar, and in that there are still files, which look familiar to a lot of people. Don't be fooled, the cub format has changed, but nevertheless it is there. And it even has the metadata in here, which is the bare stuff. But it's all there, right? So if you want to look at that stuff, it's all there. So the whole definition for the whole model, given a specification, we've backed it up in a TGZ file, and that TGZ file is immediately available for you.
So it would actually, for me mean I can automate like downloading the backup at the end, I can also upload it into the
Yes,
content.
that was the next thing. If you know, I don't. 5 minutes is not enough. But the next thing I wanted to do is what I said here: switch to other production environment, right? So if I do Ctrl-Alt-E here, and I say production, now my environment is set up to work with my OpenShift cluster. So if I go back to the top now, let's see if I can do this in 3 minutes. Again, what are my instances, right? I did create OLAPLINE apparently already. Quick check. Production, yeah. Okay. Do I have applications in here already? I did have the application too. Nice. I apparently didn't clean this. I have no databases. So I can now create that database here. That's going to take that 2 to 3 minutes, but I'm going to nevertheless do that. And what? Cannot start a database, potential database ID conflict detected. Uh-oh. Hold on, doesn't matter. Let me demo 2.
But it actually just means you just now pulling that back to a different environment and bringing in the backup, loading it up, and then you have more or less synchronized.
So if I go back here and I go to my this one now. Now, the reason that those two things existed on that environment already is because when it was almost 2 a.m. last night, I was chatting with with one of my guys, Burke, and we found an issue on this cluster. So he looked into it, and he has apparently not wiped everything. But that's fine. So if I go to the TM1 project here on the bottom, it effectively works the same way, right? So I've got my deployments, I've got my secrets and everything, and I've got my pods. And there should be, yeah, see, the old ones are still here. And there's this new pending one. That's the one I just created, right? And that's why I got that conflict, because those have the same name. They're for some reason still running, but they're not in the system anymore. He was debugging it, so I'll leave them. So I'm signing you on, again, 2-3 minutes. Same thing here. It's getting a persistent volume claim, which takes time. It's the same persistent volume claim because it's IBM cloud infrastructure, so no difference if I'm using an OpenShift cluster here or the vanilla Kubernetes to get that one done. And after that, let me show the requests already. After that, what I'm going to do, once the database exists and have created a session, I'm going to do the upload, right? So the file that I just stored on the ponymusic.tgz, right? So I'm going to create an instance in that same hidden backup sets file, a document, which with the name of the backup set that I want to give it, right? And logically. Then I'm going to upload to the content, which is simply a put to content, right, of that item. And in this case, this means read from this file. And then I verify that I have it, and then I call restore with a reference to that thing. So here it is already. So I've got the databases up. I'm going to create that session for myself. Where's my name again? Here. Now I have a session, and I should now be able to create that. Okay. 1 second. Forgot that one. What happened here is that I need to the backup sets folder doesn't exist yet. That's actually an issue in the system. The system should guarantee that that's there. But not to worry. That is very easy to fix because I can to content here. I can, oops. I can post a folder which is named .backup sets. If I do that, I have a folder backup set. Then I can create the item, and then I can send the upload. There it is. Then I can validate that I have a file now which is the same size, 931782, that we had before, and then I can call restore based on that file. That takes a minute as well, because it actually takes down the instance, rolls the instance, because it's effectively restarting the server based on all the information that's there. And when that comes back, I can show you that this one now has the same dimensions, cubes, and everything that I had in my other cluster. So now I have, in 3 minutes I have, or 5 minutes, I have the same database running in a completely different cluster. I can scale it there as well and everything, just by backup and restore.
Actually, I guess some techies out there and also sitting here could listen you for a bunch of hours if you want to and ask another questions. I would have some kind of small idea. I don't know if you would participate. So actually, we have this question and answers chat here. So users out there could like ask, maybe we make it different second sessions in a separated Teams call to ask you more questions if you would like to have it. Then maybe it's okay. So to everybody outside and also here in the room, of course. So my idea would be that you just ask a question in the question and answers now and leave your email address connected to some kinds of Teams account, and we would try to make an invitation for the afternoon somehow, and then maybe to align a different second session. I don't know how much time you would give it a go, but like maybe 1 hour or something like this. And
I can do this all day.
Yeah, so it means to just ask a bit more detailed question, a bit more direct, because it would be then a direct session. Yeah, it would be way easier to ask questions, and we can still continue with the usual things. That's an idea we will try to solve it. We will send maybe some picture outside to the live screen and then send the information outside how it could be possible. So far, thank you very much. I was totally deep dived into. I don't know how it was with you guys, but I was totally dive into, and I totally understood the concept also that will be used in the future. Understood it, and I guess it will be a huge amount of changes for the end, not only for the users, but also for all the consultant companies, for all the companies using currently APIs, current integrations, and also tools and solutions. They actively need to change all that. We understand that. I understand also the concept behind why it should be like this, because it has to go to the future, and it also has to...
Cloud is here to stay, right? And the infrastructure is here to stay. It's not so much cloud, but it's the infrastructure that the cloud was built on is what's going forward. If you are on the REST API, right, you're pretty good. Tooling that is based on the REST API, planning analytics didn't need to do that much. It's just how you get in and the session management, that's about it. I'm planning to work with, for example, Kubewise, because I use Arc myself, right? And make sure that, in a couple of weeks' time when they have their conference, we can actually, just use Arc to do the same thing. Yeah, maybe we hack it, the getting in there with the session, but after you get to the database, everything is the same effectively. So there's a lot of change, but once the infrastructure is running, like if you have the TM1 service deployed, like I just now did, I deployed the database 3 times, right? In the meantime, on a cluster, and I can scale it. I can do. I took a backup restore, moved it around halfway across the world, and this was everything with a relatively slow Wi-Fi connection, working in Montreal, right? So
it will be also actually quite fast at the end. So, yeah. So Hubert, thank you very much for this deep dive into. So for all of you outside there, this is more than the end of this session. I don't know, or you want to make a finishing sentence or something?
No,
like
it's
that's it. Okay, because it could be long sentence at the end. So
no, it could be a very short one, right? If you're, I started off with talking about 11.8, right? It's going to be a little while before everybody gets their hands on the next version of Planning Analytics, which has TM1 12 in there. But if you're not on 11.8 yet, get there as soon as you can.
So it's the most stable version out there, so it should be minimum the version. Okay.
Yeah.
So yeah, thank you very much for all those internals. I hope you also outside you REST API users outside there. I know there are some, so you already have your own products driving in your environment. So I know there will be in the future some changes, but a lot of advantages are also inside. So some problems will be solved that I'm also currently working on some company. Hopefully they will get who it is. So there will be a lot of advantages inside. So for now we will close this session a bit. We will have here some local dinner, let's say, and we'll not dinner. We'll just have a lunch here, and then we will continue with the next topic. And okay, and now I switch to Deutsch. Ja, kleine Mittagspause und danach geht es sofort weiter. Und dann geht es als nächstes in das Thema, jetzt muss ich ganz schnell überschauen, das wäre dann QB Docs, BI2Run stellt sich dann nochmal vor, also unser Partnerunternehmen, mit dem wir jetzt sehr eng zusammenarbeiten. Und da wird es auch nochmal so ein bisschen in die Internals gehen, wie man das TM1-Modell dokumentieren kann und in Übersicht behält. Ich denke, es wird knapp mit einer Viertelstunde, vielleicht draußen im Stream schon mal so ein bisschen auf einstellen. Ich denke, wir werden so paar Minuten später starten müssen, weil ansonsten haben wir das gerade hier so ein bisschen lokal ein kleines Problem, das zeitlich hinzubekommen. Aber wir bemühen uns, relativ pünktlich in dem nächsten Vortrag drin zu sein. Ja, vielen Dank euch und gute Mittagspause an alle.